statics problems again. And what do I mean by statics problems? What's happening with the motion? There is none. There's no motion. Do you remember when we did the statics problem with all forces concurrent? So when all the forces were concurrent, what was the only possible motion that could happen? Say it again. When all the forces are concurrent, coming off the same point, what was the only possible motion that could happen? Translational motion. So, and we knew since it was a statics problem, there was no translational motion. So our equations of equilibrium were what? Sum of the forces in the x equals 0. Sum of the forces in the y equals 0. Sum of the forces in the z equals 0. That's it, right? But now we're talking about full statics problems. If you look at these problems, you see beams, you see brackets. We've seen a lot, actually. We saw a lot of different kinds of bodies now. But now the structures, the bodies, have a potential of translational motion and rotational motion. And statics means they don't move. So what equilibrium equations do we have now? Still sum of the forces in the x, sum of the forces in the y, sum of the forces in the z equals 0. And now we also have sum of the moments in the x, sum of the moments in the y, and sum of the moments in the z equals 0. We're going to have a 6 by 6. We could have 6 by 6 matrices now. So if it's a 3D problem, how many equations do we have per body? 6. 3D problem. 3D problem. We have 6 equations, which means how many unknowns can we have? 6. We can have 6 unknowns. 2D problem. Think about it. Talk to the person next to you. How many equations do you have and what are they? And don't scream them out. Talk about it because you'll make the mistake quickly.
Para 2D son 6, para 2D va a ser 3, porque vas a tener force in the y, force in the x, y luego rotation about z would be 3.
So how many equations do you have? Everybody says yes, 3 equations. What are those equations? Sum of the forces in the x equals 0. Sum of the forces in the y equals 0. And? Yes! Sum of the moments in the z equals 0. So, if we have 3 equations, how many unknowns can we have? We can have 3 unknowns. And this is per body, right? Just like 6 per body. Everybody good? Yes?
Yes.
Yeah. Okay, so do you remember how we solved statics problems? What was the first thing we did? Right, we looked at the picture, we read the words, right? Look at picture, let's say sketch. Look at sketch, read word, the description, and then we do given and find. You don't have to write this down, okay? Don't write this down. I'm going to show it to you. We have it. What's the next thing we do?
The knowns and unknowns?
We tried to figure out what the knowns and unknowns were, right? And how did we do that? We made a table. We made our table. And our table had, do you remember it had forces in the first column, it had magnitude in the second column, and it had direction in the third column. But we've introduced something else besides forces now. What else do we have in there? Moments. And it's not moments that are created, it's moments that are on the system or reactions that supports. So we make the table, and from the table we determine what? The number of unknowns, and then that tells us how many equations we need, right? And then what do? We do the equilibrium equations. Is everybody remembering this process that we did? So in the packet, on page 24, it has the process. Right? That's why you don't have to write it down. Given, find, identify all the forces in the moment in the system, including the reactions and supports. We have to remember to put those in now. Determine what forces and moments, magnitudes, and directions are unknown. The number of unknowns tells us the number of equations, which tells us the number of free body diagrams. Right? Oh, I forgot to put I messed the step in here, didn't I? Step 4 is free body diagram. Right? And actually, what's step 5? Components. And when you do components, you do C-H-E-K-S. So, here, and David, this was your question the other day. Bodies no longer need to be represented as a point where concurrent forces acted. Since moments are now present, a body can be something such as a beam, a bracket, a rod, whatever it happens to be. Now we know for 2D we have 3 equations max per body. 2D. 3D we have 6 equations max. Decide which body, draw the free body diagrams, find the components, solve up your equilibrium equations, find the unknowns. Good? Ready to do a problem?
Yep.
Yeah.
So you know already how to do this. And you're experts on moments now. So, first one. I'm going to pull it down on 2 screens now, if you don't mind. Okay, so how about working with the person next to you? Read the words, look at the picture, write the given and the find. Remember, be careful with what you're calling variables. You want to make sure that whatever you decide to call a variable, that you're using that same variable throughout. Structural members loaded and supported as shown. Determine the reactions and support A and B. So take a look at point A and B and figure out what kind of supports are those, and what kind of reactions are there.
Si lo tenemos, magnitud y dirección.
Like that just looks like it's
Reactions at support A.
Yeah, just refer back to the picture. Okay, what kind of reaction, what kind of support is that A? What's A? A pin. What is that B? A roller. Okay, so what are the reactions of a pin? Remember, we're going to use this as scrap. What's the reactions at a pin? Force in the X and force in the Y. So there's an AX and an AY. And what's the reaction in a roller?
Y.
Y only. BY. It's actually really just the normal, right? It's just resting on that ball.
Just chilling.
Yeah.
Just chill. So now, going back up here, since I wanted to introduce one set of variables, determine the reactions that support A and B, well now I'm going to write AX, AY, BY. Okay, so let's figure out what other forces are around. Let's go around. Nick? So we have AX, I'm putting my table together, AY and BY. Do I know their magnitudes? No. Question mark, question mark. Do I know their directions?
Yes.
Yes. And even though I don't know if AX goes to the right or the left, I still know it goes along this way. That's a known direction. Because whether you get a positive or a negative, that's knowing the direction. Okay. Do you know which way, looking at the picture, which way it goes?
No.
What can you do in your head? Sarah?
Oh, I'm on board.
It goes what? It goes to the right. How come it goes to the right? Has nothing to do with the pin. It has to do with all the different, because they're called reactions at support. It's how is that, what forces need to be in there to balance it? It's a reaction. It's a reaction to the forces that are applied. Look at the forces that are applied. How do you know AX has to go to the right?
Because of the 300 pound?
Because there's a 300 to the left, and there's a 200 to the right, so it's got to go to the right, and how much is it? 100. What did you just do in your head?
Matrix.
Sum of the forces in the x equals 0. So we can do that with AX because there's only one unknown in the x. But what about AY and BY? There's no way quickly doing sum of the forces in the y for me to determine what AY and BY are. If I did moments in the head, some of the moments in my head I could, but then we have to do the math anyway, so why do that in my head?
So even though you can visually see that AX has to be 100 pounds, you still would write
You
that?
have to write the equilibrium equations.
Okay,
Yes.
and you still write that the magnitude is
Yeah,
in
it's like, did you guys take geometry in high school? Some of you did and some of you didn't. You remember those theorems? Like one side you had to say something and the other side, it drove me crazy for a long time.
Oh, yeah.
Until I got used to it, the proofs. Okay, well after a while I kind of got the hang of it, you know? But that's what you're doing. And I mean really, all school is about proving things, right? You're proving to us, the instructors, that you know your stuff so we can move you on to the next stuff, right? So I don't want you to do some of the forces in the X in your head. I want you to prove it to me that you really know it. Plus, you can make mistakes in your head that you usually don't make when you do it methodically. Okay, Jaden, what other forces are in the system?
Moment.
So there's no moments. There's a moment, this is an important thing. There are moments created by the 200, the 100, and the 300, but there's no concentrated moment. I didn't take a screwdriver and stick it in here and spin it, or stick it here and spin it. I didn't put a moment in, right? But what, does everybody understand? It's only if there's a moment drawn, or if the moment is a reaction to the sport, do you actually have a moment to write here. You don't write about things that are being created. Okay, so what other forces do we have, Javen?
Oh, the ones that they show in the picture.
Right, the 100, 200, and 300, and we know all their magnitudes and we know their directions, right? Okay. Aaron,
Yeah.
so how many unknowns are there?
6. Oh, I'm sorry, 3.
Right, how many equations do we need?
3?
Right, 3 equations. Equations have to equal unknowns, right? So how many bodies do I need to analyze? It's 2D.
Is that 1?
One body. And what body do you want to analyze?
A?
So we have to think about bodies now.
Oh,
We're really talking about bodies. We're not talking about points. The only time you can reduce it to a point is when? When can you reduce it to a point? If all the forces in the whole system converge on that one point. So what's our body? It's cross. So let's draw it all.
Yeah, you have an X and Y and you have a straight shape.
Do I have a complete free body diagram here? What's missing? All the distances. This is really important. A lot of times people leave off distances. If I don't have distances, what can I not calculate? Moments. In order to calculate moments, I have to have distances. And remember, this whole drawing that's given is scrap. You have to draw it. This is the free body diagram we're working off of. 2 feet, 4 feet, 2 feet, 2 feet, 3 feet. And if you want to have a class on Tuesday, we could even go through and do all the 2D statics homework together if you want. Okay, so now I'm going to write up here.